So today we're still working on 6.4 graphs of sine and cosine, but today we're going to focus on the second half of these slides, so slides 9 to 17, which are going to involve vertical shifts and phase shifts, which in essence are horizontal shifts. So a vertical shift is very much like the vertical shift that we did with quadratic equations, where we knew that, if you had an x squared plus 5, your graph was going to go up 5, or if you had x squared minus 5, it would go down 5. And so here you're going to see that you're going to have your basic parent function or some basic sine or cosine graph, and then at the end, not attached to the x, but rather separate, you're going to be adding a number or subtracting a number. And so these are vertical shifts. So this is going to be a vertical shift up 2 units. Okay, so once I have my sine graph, I'm going to take all those key values, I'm going to raise them 2 units up, and then I'm going to connect the dots again and create my wave. And here again, it's going to be a vertical shift, and it's going to be down 3 units. So when I come over to here, you notice that your A value is 1, which means your amplitude, right, is going to be the absolute value of 1 or 1. You see that your B value is 4, which means that your period is going to be 2 pi, because it's a sine graph. So 2 pi divided by B, which is 4. So your period is going to be pi over 2. And you see that your graph is going to have a vertical shift, and it's going to go up 1 unit. Okay, so the up 1 I'm going to do at the very end. So what I'm going to do is I'm first going to graph basically the other component to this, right? I'm going to graph the rest of the graph, this part sort of first. Okay, so I know that I'm going to do my 4 tick marks, and I'm going to end here at pi over 2. This is 0. And then I've got my 4 tick marks to the left, and this is going to be negative pi over 2. So come over to here. Now I have to figure out what my quarters are going to be. So I'm going to start with that. So I'm going to do a quarter of pi over 2, and that's going to be pi over 8. So that's here, pi over 8 and negative pi over 8. I'm going to do half of pi over 2, which is pi over 4. So that's here, and negative pi over 4. And I'm going to do 3/4 of pi over 2, which is 3 pi over 8, which is here and here. And now I'm going to graph, my basic sine points, right? I'm going to sort of outline these. And so I know that the basic graph, obviously this is going to be my amplitude of 1 and negative 1. I know, because I'm memorizing the basic sine graph, I know the first point is here, second, third, fourth, and fifth. So I know this is the basic wave. And then I know it's down, middle, up, and back to the middle there. And so I know that that's the basic wave. However, this is before the vertical shift up. And so I know that all of these points have to go up 1 point. So every point on this curve is going to go up 1 unit. Okay, so I go here, I go here, I go here, here, and here. And then I connect those dots. Okay, so I have here, up, down, and back up. Okay, and I know that this is up at positive 2. And so every point shifted up 1 unit, okay? Whoops, not here, here. Okay, and so so that's my graph. And so the blue graph is my final graph. The blue graph is the graph of sine of 4x plus 1. The red one is just the basic sine of 4x, and then the blue is plus 1. You can use different colors when you do this. You can do the original and then shift it up 1. You could just graph the blue one if you feel comfortable doing that. You can highlight like I know that the final answer is going to be this one. So, on an assessment or something, you can highlight this for me. Okay? But basically, that's what your graph would look like. So here, again, we have another sine graph, and I see this is a basic sine graph, and then I have -1. So I know this -1, and everything about it has like a certain factor to it, right? I know that this 1 in front of the sign, or the number I don't see, is my A value. And again, if my A value is 1, my amplitude is the absolute value of 1 or 1. My B value is the value in front of the X, which means my B is pi over 4. And this -1 means a vertical shift down 1 unit. So the B value is going to give me an interesting period that I don't think we've seen yet. I know the period is 2 pi divided by the B value, which is pi over 4. Well, 2 pi divided by pi over 4 is 2 pi times 4 over pi, which means 8. So the period is 8. So again, like we've been doing, we're going to come over here and we're going to graph. We know this is 0. And we're going to create our 3 tick marks, our 4 tick marks rather. And the period is 8, so I know it's going to end at 8. Now this one's easy because 1/4 of 8 is 2, half of 8 is 4, and 3/4 of 8 is 6. So -2, -4, -6, and -8. And again, the basic sine wave with an amplitude of 1 is going to look like it did in the last slide. It's going to be 0, 1, 0, down, up. There's the right side, and then down, up, down. And this will be the wave over here. Now, because it's a shift down, every one of these points now has to go down 1. Whoops, not that. Down 1, down 1, down, 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 and down. And again, you're going to follow along. And that's it. And so again, you realize that you had the original sine of pi x over 4, and every point was dropped down 1. And that's how you got to, the -2 as your new low and the 0 as your new high. And again, the blue graph is your final graph. So whether you show me the different ones, or let's say you highlight the final graph, somehow you have to let me know what your final graph is, but that is basically the process. Now we're going to deal with a phase shift, and a phase shift is a left-right shift or a horizontal shift, okay? And so really this will introduce the last type of change that we're going to talk about right now. So we know that, again, the A value is our amplitude, how high or how low our graph goes. It also talks, if it's negative, it's the reflection over the x-axis. The B value changes our period. Some plus or minus some number out here is a shift up or down, like we just saw, a vertical shift. And we know that anything added or subtracted to x in this parentheses is going to be a left-right shift. It's going to be a horizontal shift, just like you did with parabolas. So, and just like with parabolas and other things, the x shift is always opposite it appears. So if it's minus some number, you're going to go to the right those units. If it's plus a number, you're going to go to the left. So here are the directions for graphing with a phase shift or a horizontal shift. Basically, you're first going to look at the problem and you're going to identify your amplitude and your period. Then you're going to multiply the period by 1/4, 1/2, and 3/4 to mark your, and the first one is 0, right? The last one is the period, and those are the in-betweens. That's what we've been doing all along. And you're going to identify those markers, okay? And that's basically, those are the points where your basic sine graph or cosine graph are going to involve. Then you're going to figure out what your phase shift is. okay? Once you figure out your phase shift, you're going to add that shift to these three values plus the 0 plus the period, you know, the last one. So those 5 are going to get this added to it. You'll plot those key points on the x-axis, and then you'll identify your pattern and your amplitude and everything based on that shift. So I'm going to walk you through how to do that. So here we have a graph of y equals 1 sine of x minus pi over 3. And if you notice in this problem, your a is 1, and so your amplitude for this problem is the absolute value of 1 or 1. And you notice that your b value is 1. Okay, so your period is going to equal 2 pi over 1, which is just 2 pi. And what you're going to notice is on all the problems that have a phase shift, a horizontal shift, we are going to make sure that in those problems, the period is going to remain 2 pi in our assignment. Now, when you get to pre-calculus, it's not always the case. In pre-calculus, you can have your phase shift along with a change in period. You could have some number here in front of the x that's not 1, but we're not going to do that to you. We're going to leave anytime we include a phase shift, as we did here. Here you have a phase shift, and what this means is you've got a horizontal shift to the right, pi over 3 units. Okay, so you're going to shift your entire graph to the right, pi over 3 units. And so because we're doing this shift, we're not going to change the period on you. Okay, so let's do like the instruction says. We're basically going to create our graph. We're going to identify our amplitude and our period, which we did. We're going to come up with our 4 quarters based on our period. Our period is 2 pi, and we know that our 4 quarters are, we start at 0, we end at 2 pi, pi over 2, pi over, not pi over 4, pi over 2, pi, 3 pi over 2, and 2 pi. And the same thing here, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And so those are our basic coordinates, and we know that our shift is pi over 3. So what we're going to be doing, we're going to the right, so we're adding pi over 3 to all of our coordinates. Okay, and so that's how we're going to identify our new locations for our points. Okay, again, from here, you know, the sine graph would look like this if this is where we were at here, with an amplitude of 1 and an minus 1. Our graph would look something like this. We'd have a point here, 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 and here. And then we'd have one down here, 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 and here. And if I graph that, it'll look something like that. But because this whole graph is shifting to the right, pi over 3 units, we need to identify these key points. Okay? Right now, we know our new graph, when it shifts, is not going to go through 2 pi, negative pi, 0, pi, 2 pi. Like, these points are all going to shift to the right, pi over 3 units. So I need to figure out what those x coordinates are going to be. And so I could do it like this. I could, you know, start over here, let's say at negative 2 pi plus pi over 3. And I can do that math, right? So negative 2 pi over 1, 6 pi. That's going to equal negative 5 pi over 3. So I know that my first point here is going to be negative 5 pi over 3. So that's where this point is now going to be, okay? And then I know I have my next one. I've got negative 3 pi over 2 plus pi over 3. And I do that math. And so that's negative 9 pi. So that's negative 7 pi over 6. And so again, I come over to here, and I've got negative 7 pi over 6. Whoops, that's not where the circle goes, though. Sorry. So at negative 7 pi over 6, that's where this dot is going to be, right? Because my graph is going to go like that. Then I go to the pi, and again, I'm going to go, I have to do pi plus pi over 3, or negative pi. So that's going to be negative 2 pi over 3. And so here, I'm going to have my next point, negative 2 pi over 3, and that's going to be at 0, because again, I know that that's what that looks like. And then I take the negative 2 pi, and basically I'm adding that. And notice my denominators are different every time, so it makes it a little bit more difficult to add. So every time I shift over, you know, it's just a little bit more challenging to get my numbers, right? Because my denominators are not the same, and I have to be really good with fractions. So shifting everything to the right, pi over 3 units, is essentially adding pi over 3 to every single value. And I could start with the left and go to the right. There is a couple different deviations on this that I can do. One such thing that I could do is, I'm kind of taking it back to the original, is I could try to find a fraction. These have 2's in them in the denominator, and pi over 3 has a 3. So I know that if I'm going to add pi over 3 to everything, I could just as easily add 2 pi over 6. Now, that equals the same thing as pi over 3, but what I could do is I could come over here and I could turn these original values into numbers over 6. Like negative 12 pi over 6 is the same as 2 pi, and negative 9 pi over 6 is the same, and I could do negative 6 pi over 6 and negative 3 pi over 6. And same thing for over here. 3 pi over 6, 6 pi over 6, 9 pi over 6, and 12 pi over 6. And so those are equivalent fractions to the original, okay, except they have a denominator of 6. But that makes it really easy for me to add these in now. Because again, now I'm doing, for example, negative 12 pi over 6 plus 2 pi over 6. Well, that's easy. That's negative 10 pi over 6. And then I go to negative 9 pi and I add it, and I know that that's negative 7 pi over 6. And then from 6 pi over 6, or negative 6 pi, it becomes negative 4 pi over 6. And this one becomes negative pi over 6. And then again here to the right, I can get the right of 0. I've got 2 pi over 6. That's 2 pi over 6 units away from 0. I go this way to 5 pi over 6. I go this way to 8 pi over 6. I go here to 11 pi over 6. And I go here to 14 pi over 6. So once you saw that I made the denominator the same, it was super easy to add 2 pi over 6 to everything. Okay, and so I know that my new coordinates are going to be those, and so I can sort of get rid of these original ones, which no longer are going to be valid, right, because my graph shifted from those. So let me show you what this might look like here. Like that. And so now I know that my new graph is going to be, let's do it in blue, it's going to be here, 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 here. Then I'm going to go up to here, down to here, and up to here. And so my graph looks like this. Notice all my points are just a little bit shifted to the right. And those are my actual coordinates, the ones that are there now. So it's these. Now, these are not all simplified, and you could work a little bit harder to simplify these. Once you do all the math, negative 10 pi over 6 is the same as minus 5 pi over 3. This one is fine. 4 pi over 6 does simplify to negative 2 pi over 3. This one's fine. This one simplifies to pi over 3. This one here stays the same. This one becomes 4 pi over 3. 11 pi over 6 stays the same. And 14 pi over 6 is 7 pi over 3. And so, again, here's your coordinates for your thing. Let me make sure I got them all here. This. These are all my shifted x values, okay, simplified. And again, the blue graph is the graph. And so I find that a little bit helpful, and I think that is a pretty decent way of doing this. So that's what I would do. I personally would find a common denominator between my shift and my original graph, and I would put everything in this with the same denominator, which makes it super easy to add or subtract some value. But again, my graph just shifted over, all my red points shifted over this many, pi over 3 units to the right, and that's my new graph, the blue. Now in this one, I'm going to show you an alternative method that we sort of discussed a little bit in class today. So again, here we have our a value is 2, well, not capital A. Our lowercase a value is 2, and that means that our amplitude is the absolute value of 2 or 2. And we know that our period is going to be, because b is 1, we know our period is 2 pi. And like I said, when we do a phase shift here, we're not going to change the period on you. We're going to leave it at 2 pi. So this is shifting pi over 4 units to the left. So what we're going to do is we're going to draw the original graph here, okay, with our original 2 pi period, right? Our 4 tick marks, 1, 2, 3, 4, 2 pi. And we know that these, because we've done these so many now, it's pi over 2, pi, 3 pi over 2, and 2 pi. So we're just going to do the right side for right now. And what we're going to do is we're going to notice something, that between, from 0, where our first point goes, to here, we see that this is plus pi over 2 units. And from here to here, it's plus pi over 2 units. From here to here, it's plus pi over 2. And from here to here, it's plus pi over 2. So each quarter represents pi over 2 units. Now, where does that come from? Well, we have to think of our period is 2 pi. And if I was to divide my period into 4 pieces, each piece would be worth pi over 2. So this plus pi over 2, plus pi over 2, and if I was to go in the other direction, it would be minus pi over 2, minus pi over 2, to get to these, okay? It would be minus pi over 2 also 4 times to the left. And again, the reason we're adding and subtracting pi over 2 is because we're breaking up our period into 4 quarters, which in each quarter is pi over 2. Since all of our phase shifts that we're going to do in this chapter have a period of 2 pi, well, then from one point to the other, there's always going to be pi over 2 radians between it. So why do I tell you that there's this, and where does this come from? Well, because if the second way that we can do this whole shifting process, okay, is to start by the original shift. Start focusing on the original shift. So originally, my first point is always here at 0, 0. But because I'm shifting to the left, pi over 4 units, I know that my first point is going to be located here at negative pi over 4. Well, once I find that first point, I know that all my other points are going to be pi over 2 units apart. So, for example, my next point over here, I'm going to add to this negative pi over 4, I'm going to add pi over 2 units, which is the same as 2 pi over 4 units, just to have the same denominator. And I'm going to get pi over 4. So I know this point here is pi over 4. And I know I'm going to add another pi over 2 here. So I'll do pi over 4 plus 2 pi over 4, which is the same as pi over 2. And I'm going to get 3 pi over 4. So this is located at 3 pi over 4. I'm going to do another one here. Okay. I'm going to add to 3 pi over 4. I'm going to add pi over 2, which is also 2 pi over 4. And that gives me 5 pi over 4. And I think I might be, no, I still have one more to go. And then I have one more. Let me do one more over here, and I'm going to go 5 pi over 4 plus 2 pi over 4, and that's 7 pi over 4. Okay, and so now I know what my sine graph looks like, and I know that my amplitude is 2. So I should be able to draw it. Let me kind of erase these little things I did here in between to kind of do that plus pi over 2 thing. Okay, and I can also eliminate the originals because I don't need those. And so I just realized this is a cosine wave. And so I know my first point is going to originate at negative pi over 4 because that was my shift from 0. Because it's a cosine graph, I know that point is actually up here. Okay, so my second point, pi over 4 here, will be my 0. 3 pi over 4 will be my negative 2. 5 pi over 4 will be back at 0. And 7 pi over 4, I'll be back up at 2. Because again, remember, this is the cosine wave. Okay? And when I come to the left side, I'm going to be doing the same thing. I'm going to have to go to the left minus pi over 2 units for every single one of these coordinates that I'm going to try to find. Okay? And one more here. Okay? So I'm going to constantly be subtracting negative pi over 2. Well, negative pi over 2 I know is equal to negative 2 pi over 4. So when I do negative pi over 4 minus 2 pi over 4, I get minus 3 pi over 4. When I subtract minus 2 pi over 4 again, I get minus pi over 4. I get minus 7 pi over 4. And I get minus 9 pi over 4. Okay? And so those are my values to the left. And again, I know that I'm going to go from here to here. This is my 0. Down here, this is my negative 2. Up here, I'm back at 0. And up here, I'll do my 2. And there's my wave again. Okay, and so that's how you get your wave, and that's how you do it. So again, the tricky part is understanding the very first shift, okay, because that first shift is going to be here. It's going to be the negative pi over 4. That's going to take you to the x value where you're going to get your first part of your wave or your period. And then you're going to go to the right plus pi over 2 units, and you're going to go to the left minus pi over 2 units from there. So I don't know which method you prefer. Either one is fine with me. All right, so again here we have a couple more. Here we have minus 2, so we know that our A value equals negative 2, which means our amplitude is the absolute value of negative 2 or 2. And we know that our period is going to be 2 pi because there's a phase shift, okay? Because this is a negative, I know my graph is going to eventually also reflect. Okay, now this one, I actually love this one because, and I'll show you why, again, when we're in a 2 pi scenario, we know that when we divvy everything up into its quarters, the quarters are going to be adding pi over 2 every time. So I know if this is 2 pi and this is 0, this is 1 pi over 2, this is 2 pi over 2 or pi, this is 3 pi over 2, and 2 pi over 2 is the same as 4 pi over 2. And so, or 2 pi is the same as 4 pi over 2. So I know everything is broken up in these units, and the same thing goes for the other side. So negative pi, I have negative 3 pi over 2, and I have negative 2 pi. And so I know it's a sine graph, and normally, again, we're going to be doing a couple versions of it, but I know my very first point is always here. However, there's a shift here, okay? And I know that this is shifting to the right pi over 2 units. So my starting point is shifting to the right pi over 2 units. So my new starting point is going to be here. Okay, I'm going to start at pi over 2. Now, the benefit here is I know that from that starting point, I'm going to go plus pi over 2 units to the right and minus pi over 2 to the left. Well, plus pi over 2 takes me to this tick mark, which is really nice. So I know that, let's say, this will be 2, and this is negative 2. So I know this will go here to 2. Then it's going to go back to 0. Then it's going to go to negative 2. And here I'm going to have to add one more pi over 2. So this is 4 pi over 2 plus pi over 2 is 5 pi over 2. And that's where it's going to end. So my sine curve looks like that so far. And again, I'm going to do the same in the other direction. So this is going to be here. This is here. This one's up here. Did I do that right? 1, 2. Oh, and this one ends here. Yeah. And so there's my sine curve, even though it's not super pretty. But there's my sine wave. Everything shifted over, right? Pi over 2 units. Now the problem is that's the sine curve of positive 2. That's not the sine curve of negative 2. So I do have to come here and reflect this. So when I reflect it, all my x's are going to stay the same. I mean my zeros rather. So 0, 0, 0, 0, and 0. Now my y's are going to flip. So this one's going to come down. This one's going to go up. This one's going to come down, the one there. And then I'm going to come here, and then this bottom one's going to go up and here. And so the red graph is the finished product. The red graph is the final. It is the reflected version of the blue one. So again, you can graph both for me, or you could graph one. You can highlight the one you want to keep and get rid of it. But what I'm looking for is the correct wave. I'm looking for the correct shift, okay, that everything shifted over pi over 2 units to the right. And I'm going to look for these values to make sure that all these values are written correctly, okay, these intervals. And last one. So again here we have an A value of a half, or A is a half, so we know the amplitude equals the absolute value of the half, or a half. We've got our B value is 1, so we know our period is 2 pi. And we have that our shift is going to be a horizontal shift, and it's going to be pi over 12 units to the right. Okay, so when I come over to here, I initially start with my graph. And again, I'll do this, let me see which method I choose. Maybe I'll do this one, Miss Ferrier's method. I know that I'm shifting pi over 12 to the right. So again, I know what my originals are. Pi over 2, pi, we've got 3 pi over 2, and we have 2 pi. And we have the same here for negatives. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And we're shifting pi over 12 to the right. So to every one of these values, I have to add pi over 12. Again, that is one method of doing this. So if I'm going to do it that way, it's probably wise that I make my denominators 12. And so let's do kind of like that calculation. if my denominator is 12, I'll tell you what these will be. This will be negative 24 pi over 2, or over 12, right? And that's going to be 12 over negative 18 pi. And this is going to be negative 12 pi over 12. It's going to be negative 6 pi over 12. This one's still going to be 0. This one over here is going to be 6 pi over 12. This is 12 pi over 12. This one's going to be 18 pi over 12. And this is going to be 24 pi over 12. Okay, so those are going to be those coordinates above with a denominator of 12. And if I'm basically adding pi over 12 to each one, then I know that my new values are going to be here. If I'm adding pi over 12, this is going to be 23 pi over 12. This one is going to be minus 17 pi over 12. This one here is going to be minus 11 pi over 12. This one's going to be minus 5 pi over 12. Over on this side, it's going to be pi over 12. This one here is going to be 7 pi over 12. This one here is going to be 13 pi over 12. This one's going to be 19 pi over 12. And this new one is going to be 25 pi over 12. And so those are going to be all of my coordinates shifted 1 unit, pi over 12 units to the right. So these will disappear. Okay, these originals here will disappear completely. Okay, I don't need them anymore. I have my new values. And then these will go away. This will go away. This gone, 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 and gone. And so now I have my new values. So again, my shift was pi over 12 to the right. That's where the basic, and it's a cosine, so I know this goes, my amplitude is a half, so this is a half. So it's going to go, it's going to start at here. It's going to go to here. It's going to go down to negative a half here. It's going to go down to here, back up to here, and over to a half here. And so my graph looks like this. And then I'm going to go here at 0, here at my minimum, back at 0, and back to my maximum. And so that's going to be the two cosine curves, okay? And again, I'm starting here. That's what used to be at 0, but it shifted over pi over 12 units. And so that kind of becomes my new starting point. And then everything else is to the right, separated by pi over 2 units each time. And everything is going to be separated to the left. Now, I didn't add pi over 2, pi over 2, pi over 2, because what I did was I just added the shift. Okay, I did it kind of like my way, the way I taught you at the beginning. If you wanted to do the adding the pi over 2, you'd come over to here, and you would identify how you would have started this is you would have identified just the shift. Okay, so let me kind of go back here and show you what that might look like. Again, this is just the other way to do it, and we've taught you both now. Now you just have to figure out which method you prefer to do, okay? But when you come here and you see this pi over 12 shift to the right, you know that if this is pi over 12, that's going to be your starting point. And in a cosine graph, that's your first point up there at the high, the max, the half, okay? And now each point is going to be pi over 2 units to the right of that. So pi over 2 in terms of a denominator of 12 is equal to 6 pi over 12. That's pi over 2. So you're going to add 6 pi over 12 to pi over 12. And so you know your next value is going to be 7 pi over 12. Then when I add pi over 2 again, or 6 pi over 12, I'm going to get 13 pi over 12. And when I do it again, add the pi over 2, I'm going to be getting 19 pi over 12. And when I do it one last time, I'm going to get 25 pi over 12. Okay? And so I know that that's going to be, those are going to be my values. So this is going to be my 0, this is my minimum, here's back at 0, and here's my max. And my graph looks like that. Okay? And so again, now I'll do the thing to the left. I'll start at pi over 12 again, because this is kind of like my center, and I'm going to subtract pi over 2 to both sides. So I know when I subtract it, this is going to be at negative 5 pi over 12. The next one's going to be at negative 11 pi over 12. The next one's going to be negative 17 pi over 12. And the next one's going to be negative 23 pi over 12. And again, we get the same answers, and we can still do our thing here, here, down to half, up to 0, or something like that, and then back up to the half, something like that. And you get your two cosine waves, rather. So however you come up with these values, like I said, I'm totally okay with it. There are two totally different methods, and you have to really figure out which method you prefer. And once you do, you can do your waves.